Well, hello YouTube. Now this video is going to be broken down into three parts. So let's first give you a little preview at what we'll be creating. You have these two game objects in our scene hierarchy, and they're nothing more than just a little enemy running around, and they have this shooter class attached to it. You can largely ignore everything else. We're going to be drawing our eyes to this shooter class. This class is going to have a bunch of different serialized fields that you can modify in your own way so that you can develop your own sort of generic bullet hell type system. For example, this one is firing in bursts with 3 at a time and 6 projectiles per burst at an angle spread of 105 degrees. This other ghost game object is going to be firing 1 bullet at a time with our stagger and oscillate properties triggered, so it's going to kind of spray and pray back and forth. So let's go ahead and hit play just to give you a nice little preview. This ghost over here on the right is going to be arcing towards the player 3 bursts at a time. This ghost down here, however, is going to oscillate and stagger back and forth in somewhat of a spray and pray sort of pattern. Now this is a nice and powerful class that's easily modifiable. However, the 3 lectures inside of this video are taken a bit out of context. These 3 lectures are part of a more fully comprehensive 2D top-down pixel course that I've done with GameDev.tv. However, I think this video can be really helpful to you if you're trying to just develop your own bullet hell type of system. So all you really need to know before you dive in is this shooter class can be attached to any sort of game object, and when they get within range, you're instantiating a bullet. Now this bullet that's being instantiated has this projectile class attached to it, and that's what gives it movement. You can largely ignore all of this. That's what's doing damage and knockback if it hits the player. But all you really need to know is that it's moving with transform.translate using vector3.write. And in our shooter class, when this bullet is instantiated, don't worry about all this, I know it looks confusing, we'll get to it in just a second and build it from scratch, but all you really need to know is when the bullet is being instantiated, we're just setting newBullet.transform.write to the specific direction that the bullet wants to move towards. And that's all you really need to know before we dive in. So with that set up, and with no further ado, let's hop into the 3 lectures, and hopefully it can be helpful to you generating your own bullet hell type class system somewhat out of context. Hello and welcome back. In this lecture, let's not only get our ghost shooter class firing 1 bullet at a time, but firing in bursts in quick, short succession. Let's get that set up. I'm going to go ahead and deactivate all my ghosts but one just to give us a nice clean slate to work with. And let's head into our shooter class. With that opened up, let's create a couple serialized fields that we can use. I think the easiest one to set up first is a private float for a bullet move speed. Now your knee-jerk reaction is probably saying, well, the bullet move speed is in the projectile class itself. So right below update projectile range, I'm actually just going to copy this whole method. It might not be the fastest way to do it, but let's also update our bullet speed move range. So update move speed. It's going to take in a float called move speed, and it's just going to update this move speed variable up top. So this dot move speed equals move speed. That way each individual shooter mono behavior can have their own bullet move speed attached to it. Then all we need to do after we instantiate a new bullet is go into our bullet projectile class and update its move speed. Now we could do that the normal way by just going into our new bullet and then getting the projectile component, but I'd like to show you a different way to do that. So the way we do that is type if new bullet dot try get component out projectile projectile. Now this is kind of a fancy schmancy syntax, but what this out keyword allows us to do is take a method or a function, pass through a parameter, modify that parameter, and then access it outside of the function. It also allows us to return multiple data types. So instead of just having, say, a private bool function that returns a single bool data type, you could just have a private void function that returns as many parameters as you want. For example, you've probably seen them used before in something like a raycast. But since we're getting towards the end of the course, let's start introducing you to some more of that fancy schmancy we're cool programmers intermediate syntax. So once we've got that projectile, then we can just go into the projectile class, update the move speed, and pass through the bullet move speed as a parameter. Very nice. Next up, let's have another serialized field for the amount of bursts that we want to fire. So private int burst count. And I think it makes sense to do another private serialized field for a float called time between bursts. That way we can move this entire logic into a coroutine and just wait at this designated float time in between bursts and fire our projectiles out in bursts that way. So let's move it down to a coroutine. Private IE enumerator, we'll call it shoot routine. We can shift all of this logic down here, following a similar structure to how we've set it up before with an isShooting bool. So up top, we'll create a private bool called isShooting, initialize it to false, and in attack, check and see if is not shooting. Then we can just go ahead and start that coroutine, start coroutine, shoot routine. At the beginning of our shoot routine, let's set isShooting to true, and at the end of the routine, let's set isShooting to false, but not before we yield, return, new, wait 4 seconds, add another serialized field that I'll call rest time. So up top, serialized field, private, float, rest time, and I'll just initialize that at 1. This can work nicely in tandem with our cooldown in our enemy AI state machine, just depending on how you want to set up your cooldowns in between the overall attack, in between bursts, and combine them however you'd like. Next up, let's actually get our bursts firing correctly. So for that, we'll use a for loop. Inside of this for loop, we'll start with I equals 0. And if I is less than the burst count, then we'll add to I. Inside of this for loop, I think we can throw all these 5 or 6 lines inside of the for loop. And before we move on in between each loop, let's yield, return, new, wait 4 seconds, time between bursts. Beautiful. All right, sweet. Let's go back into Unity and give it a try. Let's click our ghost, scroll down to the shooter class. I'm going to change my bullet speed to something not too fast, just so we can see it. Let's have a burst count of 5, time between bursts. Let's do it something real quick, 0.3. And I don't really think we need much of a rest time, so we'll just set it at 0.5 seconds for now. Let's click play and give it a shot. All right, as soon as we get within range, perfect. We've got our ghost firing towards our player. Everything seems to be working as intended so far, and it's already looking pretty good. In the next lecture, let's set up it firing not only in bursts, but what if we want each burst to fire numerous bullets all at the same time? When you're ready for the next lecture, I will see you there. Hello and welcome back. Let's not only get our projectiles firing out in bursts, let's also set it up so that we can change the angle of influence in the inspector to dedicate not only the angle on which the projectiles come out, but how many projectiles come out in each burst. Let's get that set up. All right, so at the top of our shooter class, we're also going to need a serialized field for another private int that I'm going to call projectiles per burst. Let's also create another serialized field that's going to be a private float. We're going to call it the angle spread, but we have to make sure that in the inspector, you can only set the range in between 0 and 359, just 1 degree short of a full circle. The last one we'll need for now is one more private float that I'm going to call starting distance. And that's going to be the distance that the bullet spawns away from the transform that the shooter class is attached to. And it does have to be a number greater than 0, so for now, I'll just initialize it as 0.1f. Below here, let's set up some trigonometry math using sine and cosine to get our angle populating correctly. So we're going to need quite a few properties. Hold on with me, it's going to look complicated up front, but I think once you break it down line by line, it starts to simplify itself. We're going to need a lot of different floats, so we'll just define them one by one. Let's start with a target angle, and that's going to be mathf.atan2, which looking right here returns the angle in radians, whose tangent is y divided by x. It's the same atan2 that we used for the sword rotation early on. And we're going to use this vector to target direction of where our player is to find our target angle. So let's actually just promote that up a few lines. And then inside atan2, we can use target direction.y divided by target direction.x. And then we're going to times it by mathf.rad2 to get it back into degrees. Before we move on, let's look at a nice diagram slideshow that can help us compartmentalize what we're really trying to accomplish. We're about to introduce a handful of float properties, and it can be a little bit confusing as I type them out going from top to bottom. So let's first explain what we're really trying to accomplish with each individual float. First of all, we have our shooter as defined by our ghost currently. Well, we have our target direction and we just defined our target angle, but here's where we start to introduce the angle spread that we defined as a property up top that can be manually set in the inspector. Now to spawn projectiles within this cone, we'll also want to keep track of the start angle and the end angle. But to calculate these 2 points, well, we're also going to need to know the half angle spread. This makes life just a bit easier because the start and end points are just plus or minus the same number of degrees from the center target angle. From here, we can then evenly distribute the number of projectiles in our burst between the start and end points. And to do that, we'll need to calculate the angle step in between each projectile fired shot. All right, with that explanation, let's head back into our shooter class and define some of those floats. We're also going to need a float for the start angle that we'll initialize as the target angle, as well as an end angle and a current angle. So I'm just going to duplicate that twice. We'll need an end angle and a current angle. We're going to need another float called half angle spread that we'll just set to 0 for now, and one more float called angle step that we'll also initialize as 0 to begin with. Now, if the angle spread is not set to 0, then we want to redefine some of those properties. If the angle spread is set to 0 and we just want it to go in a straight line towards the player, then we can completely ignore some of this logic. But if the angle spread is not set to 0, we need to start defining that cone of influence defined by our angle properties set up top in the inspector. So our angle step is going to be equal to the angle spread divided by the projectiles per burst minus 1. So just as an example, if our angle spread was set to something like 80 degrees and each burst has 7 projectiles, well, we then take the float of 80 divided by the amount of projectiles 7 minus 1, giving us 6. So we take the float of 80 divided by 6, and that will give us our angle step. The half angle spread is going to be equal to the angle spread divided by 2. The start angle is going to be equal to the target angle minus the half angle spread. And if we remember our diagram, the target angle is that direct line towards the target. If we add or subtract half of the angle spread, well, then we're going to get one of those 2 endpoints on either side of the cone. The end angle is equal to the target angle plus the half angle spread. And lastly, the current angle is equal to the start angle. And that way this current angle is going to start out at the starting angle, which defines the first bullet of the first burst. And then we can use these angle steps, the half angle step and our end angle, to find the proper amount that we want to shift our bullet each individual instantiated bullet. I think that'll make a bit more sense when you see it in practice. We can now start to use a lot of these properties to instantiate our bullet at a specific XY vector 2 away from our transform. So let's actually do that in its own separate function. Down below, let's find that vector 2 on where we want to spawn each individual bullet. We'll call it find bullet spawn pause for position. And it's going to take in a float for the current angle. We're going to want to create a vector 2 that I'm going to call pause, and it's going to be a new vector 2 that's going to take in the x and y floats that we're about to determine. Because we're returning a vector 2, we'll return that pause. Up here, let's define those x and y values. So we're going to need a float x and a float y. Float x is going to be equal to the transform.position of our ghost plus the starting distance for how far away we want to start our bullet away from its transform times the complicated part mathf.cosine of our current angle times mathf.degrees to radians. I'll leave some Unity documentation links in the resources below if you need to refresh yourself on cosine and sine properties, as I often have to as well. For y, we're going to use sine. So transform.position.y plus starting distance times mathf.not cosine but sine. And it's also going to take in the current angle times mathf.degrees to radians. All right, looking good. We're going to then use those x and y floats, plug them into a brand new vector 2, and then return that position using this friendly trigonometry function. Let's copy this find bullet spawn position And right above where we want to instantiate a new bullet, let's create a new vector 2 that I'm going to call pause, and it's going to be equal to that function that we just created, which was find bullet spawn position, and it takes in the current angle float that we defined up here. Now, instead of instantiating at our transform.position, let's instantiate each individual bullet at this vector 2 position. So bullet prefab instantiated at pause with quaternion.identity. Now, instead of the bullet.right transform equaling the target direction, we want each individual new bullet.transform.right to be equal to the new bullet.transform.position minus the transform.position. So because our new bullet is going to spawn just a little bit away from the shooter transform that this class is attached to, we can subtract the transform.position of the shooter model behavior itself, and it's going to give us that correct direction that the bullet is headed towards. After we instantiate each individual bullet, we want to add to our current angle, adding the current angle to itself plus the angle step. And that will give us each individual step in between each individual bullet on our cone of influence. We need to put another nested for loop inside of this for loop that already exists, since we need to fire so many bullets per burst. So right up here, I'm just going to give us some space and create another for loop, except instead of using I, we'll just use the common syntax of J. We'll start J at 0, and if J is less than the projectiles per burst, we'll add to J, and then we can throw all of this logic going down to our current angle step and just shift it up into that nested for loop. In between each burst, however, we need to set our current angle back to the starting angle. All right, let's head back into Unity and give it a try. Let's go ahead and click our ghost, scroll down to our shooter class, and we're going to need to update this projectiles per burst to be a non-zero number. I'm just going to do 6 and increase my angle spread to something wide but not too wide, just so we can really see what's going on. I'm going to have my starting distance be at 0.1, that's fine. It'll just be instantiated basically on the ghost itself. Let's go ahead and hit play and see if we've broken anything. All right, yeah. Hey, that looks pretty good already. You can see once we enter the attacking range of our ghost, it does indeed fire each individual burst properly, angled towards the player. But I'm going to show you one little thing that I'd like to adjust. Let's ramp this up to something a little bit ridiculous, like projectiles per burst up to 20, and shrink the angle spread just a little bit, with the time in between bursts of being something like 1.5, so significantly longer. When I click play and we enter within attacking range, okay, that was a bit ridiculous, but the point that I'm trying to make is you can see that the burst angle of our cone of influence, even though my player has moved all the way down here, was still pointing to the left. So just to show you that again, it's pointing down, I'm moving over here to the left, and throughout all 5 bursts, it's still going directly south. I'd like it so that in between each burst, we redefine where the player is so that each individual burst shoots towards the player. And it might be easier than you'd think. Let's head back into our shooter class. So in between each burst, we're going to have to redefine all of these variables. So I think the best way to do that is if we highlight all the way from my line 41 all the way up to line 27, the top of our target direction and the bottom of redefining our current angle to our start angle. With all of this highlighted, you can hover over to this little light bulb or press Control+ for the hotkey and just click Extract Method. That's going to automatically put this whole method down here that it's named new method by default, and now we can call this function whenever we want to redefine all of these variables, and it's automatically for us given the parameters that we needed as out parameters that we can use inside of our shoot routine. So I'm going to go ahead, press new method, press Control D just to highlight both new methods, and I'm going to call it target cone of influence. I think I spelled that right. So we're not only going to get our target cone of influence right at the beginning of our shoot routine, but I'm going to copy this entire line, including the parameters. I'd also like to call it at the end of each burst. So right below yield return new wait for seconds, time between bursts, I'm going to redefine where my player is so that each individual burst is targeted towards the player. Let's head back into Unity and see if that's working as intended. All right, I'm going to click my ghost. I think my angle arc was a bit too ridiculous. I'm still just going to shrink that down quite a bit to something really small. Change my projectiles per burst to 10, not too important. All right, in attack range, and yes, it looks like it in between each individual burst, it is aiming towards the player. All right, we are set to go. And this is already starting to get really powerful. You could have a plethora of different enemies that all use this shooter class in different ways. Now, we're not done yet, but I'd like to show you just how fun this can be. I'm going to increase my angle spread all the way up to a full circle, increase my projectiles per burst to something ridiculous like, I don't know, 40. We're going to make that burst count also something really high. 8, bullet move speed is 12. I'm really just throwing in random numbers just to kind of give you an idea of how customizable this is. We'll keep the starting distance the same and the time between bursts, let's do it nice quick succession, something like 0.3. Let's blow up our game view for cinematic effect, hit play, and watch it all come together. Yeah. Oh, baby. That is looking good. The endless options that we have with our shooter class are going to keep me busy for a long, long time. Well done on this lecture. We're making some great progress. I've got just a few more things I'd like to include in our shooter class before we move on and wrap up our shooter class entirely. When you're ready to head into the next one, I'll see you there. Hello and welcome back. In this lecture, I'd like to add a little bit more depth to our shooter class, adding both oscillate and stagger properties. Let's get that set up. Let's start by adding those two serialized fields as bools that we can modify in the inspector. So number one, bool, I'm going to call it stagger, and I'll have a second one called oscillate. With stagger, we can get each individual bullet in our burst firing one at a time, and oscillating, we can get it to oscillate or ping pong back and forth in between each burst. Let's handle staggering first, since I think it's a little bit easier to wrap our head around with what we currently have set up. Below our start, current, and angle step, let's create a new float that we can define as our time between, not bursts, but projectiles. And we'll just start that defined as 0. Below our target cone of influence, let's go ahead and say if stagger is enabled, then we want to make time between projectiles equal to time between bursts divided by projectiles per burst. You could divide this in between a couple different lines as such, but I'm just going to keep it all in one line. I think it looks a little more clean in this context. So if we're staggering, we can use this float time between projectiles and just check down here at the bottom of each individual instantiated bullet. So right after we increase our current angle by our current angle step, we can just say if stagger, then yield return new wait for seconds, and then pass in our time between projectiles float that we defined up top. All right, with stagger rigged up, let's go try that out in Unity and see what it looks like. I'm going to go ahead and just change a few properties on my shooter class. Let's keep the bullet move speed at 5. Let's change the burst count just to 3, and projectiles per burst, let's change it to something like 8, and then I'm going to drastically reduce my angle spread. I think a starting distance of something just a little bit bigger, around 0.3, might look a little bit more clean. Time between bursts, let's make it 1 just to make everything nice and crystal clear, and the rest time is not all too important for now. Let's enable our stagger property, give it a play, and we'll see what it looks like. I've got each individual bullet coming out one at a time in a nice spray and pray sort of pattern. I think that looks really good. Now this is in no way that important, but I've got my bullet just a little bit too white. I think it conflicts with some of our other white glowy materials. I think I'd like it to be sort of an off purplish pink color. So with the bullet sprite renderer still just that little bit of an offset blue, I'm just going to increase my red just a tad, just to kind of give it that nice purplish pinkish tint. I think that looks a little bit more defined on our green grass. All right, back into our shooter class and let's set up Oscillate. Now this one can be a tad more tricky to wrap our head around, but what I'm going to do is I'm going to take this target cone of influence that we're redefining at the end of our I loop. I'm just going to cut it out and plop it to the top of our I loop. And we're going to check and redefine our target cone of influence if we're not oscillating. So I'll go ahead and just wrap it up as such. Else, if it is oscillating, then I'd like to redefine a couple of my properties. I want to change my current angle equal to my end angle to get that back and forth motion. Now in our target cone of influence, we weren't outputting our end angle float. So let's go ahead and set up our target cone of influence function to do that. So out, end, angle. Down here in our target cone of influence, well, all we need to do is also out our end angle. And instead of defining it from scratch, we can just go ahead and delete that float wording. Make sure that we don't just put out, we put out float, and we're set to go there. Now we have our target cone of influence function outputting our end angle float as well, so we can use it up top. So now we just have to make sure both this target cone of influence and this function up top are both outputting our out end angle. By our start, current, and angle step, we also just need to make sure we're defining our end angle up top here as well, and it'll get rid of all those compilation errors. Great. Now back down here, when we set our current angle to our end angle, if it's oscillating, then we also want to set our end angle back to our start angle back to our current angle, and our angle step, we'd like to reverse it, so we just need to times it by -1 to get it oscillating back in the other direction. Let's go try that out back in Unity. Down here on our shooter class, let's enable this oscillate property. I'm going to go ahead and blow up my game view just so we can see it a little bit more crystal clear. All right, we've got it firing one direction, and yes, we've got it firing back in the other direction. You can see that it's going back and forth and oscillating in between each burst. Now I'm just going to try something. Let's put our burst count something a little bit higher. 8 projectiles per burst is fine, and our time between bursts, we'll keep that at 1. All right, perfect. We've got it oscillating back and forth, but we have a similar issue to what we had before. It's firing each individual burst from this top right to bottom left sort of direction because that's where our player originally was when we defined our cone of influence. So if I walk all the way over here to the bottom right, we've got the same issue. Now that's not an issue if we're not oscillating, but if we're oscillating, I'd like it to still be pointing towards the player. So the way that I'm going to handle that is with a modulus operator. So down here, when we check if it's not oscillating, well, that looks good. I'm just going to go ahead and close that off. And right below here, let's also check that if oscillating and using the modulus operator, if I modulus 2 is not equal to 1, then let's redefine our target cone of influence. Now, just as a reminder, this modulus operator is going to check and say, hey, if we take I and divide it by 2, does it have a remainder of 1? And if it doesn't, then go ahead and redefine our target cone of influence. So instead of just else, let's go ahead and say else if, just to make sure it's still oscillating. And then we can throw in all this oscillating redefining logic here. Get rid of that, and I think we look pretty good. All right, let's go ahead and give that a try back in Unity. All right, let's approach our ghost. We've got it one burst, it's oscillating back and forth to the other direction. And that wasn't a very good example, but if I come back over here, we're still in the same burst cycle, and we're now pointing towards the player every other oscillation. And hey, you know what? I think that looks pretty good. Just to try something fun, I'm going to go ahead and up my bullet speed. Burst count, something ridiculous like 12, and projectile bursts, also something ridiculous, maybe something like 14. Increase my angle spread just a tad, and my time between bursts, something like 1. Let's go ahead and click play and just kind of see what that looks like. Cool, we've got it oscillating back and forth. But you know, one more thing that I'd like to change is I'd kind of like this ghost to have somewhat of a spray and pray sort of model. I don't really want there to be a wait time in between each individual burst. I'd kind of like it to just continually oscillate back and forth. Well, luckily that's just one simple fix. Let's go ahead and back in our shooter script where we're waiting in between time bursts. I'm just going to say only use that yield if we're not staggering. So I'm going to set it up just like this. I'm going to go ahead and cut that out. And now we should only wait in between time bursts if we're not staggering. Let's try this line out back in Unity. All right, yeah, you know what? We've got it oscillating back and forth in a bit of a spray and pray. And every other burst, we redefine where our player is and it starts aiming towards that direction. Now, just for dramatic effect, I'm going to go ahead and duplicate my ghost just a couple times. This will probably be a bit ridiculous. Hey, you know what? That looks pretty good. It's a very powerful shooter class system. I think I'm ready to move on, but I can't wait to see what you've come up with. I'd love to see a screenshot, GIF, or video in our community forums. Our shooter class system looks good. When you're ready to move on, I will see you in the next lecture. And there you have it. If this sort of thing was helpful to you and you'd like to learn more, I'll leave the link below to the full course on GameDev.tv in the description below, but I'm hoping that this can help you out of context in generating your own bullet hell class type system. If you have any questions or comments, leave them down below and I'll make sure to address them. And if this video was helpful to you, go ahead and leave a thumbs up. Until next time, signing off.